All right, so this is a short video covering some examples from chapter 1.1 in our Survey of Mathematics class, Math 1130. And these are the types of questions you will see on your homework assignments. So let's go through a few of these so that you are prepared to do your homework. All right, so when it says to use inductive reasoning to predict the next number in a list of numbers, this is chapter 1.1 on page 11 of your book. I'm going to do some of the even numbered problems. Your homework assignments are generally odd numbered problems so that you can check the answers in the back of the book. So these will serve as examples. So all you're really doing here in numbers 2, 6, and 8 are looking for patterns, right? You're looking for some sort of pattern between the numbers in the list. So here, if we look at this, we see there's a difference of 6. And then between these two numbers, oh, a difference of 6. Between these two numbers, oh, a difference of 6. And we can see that's the same pattern for each difference between all these numbers. So all we got to do to complete the list here is add 6 to the number 35 and come up with our answer of 41. And you do the same thing for each of these lists. You look for a pattern. All right, so here we see 70 is 10 less than this number. And then we look at the difference here and we see 61 is 9 less than this number. And then we look at the difference here and we see 53 is 8 less than this number. So we start to see a pattern. We just confirm that 7 less, 6 less. So we're subtracting one number less than the previous each time in the sequence. We're subtracting 10 to get to 70, subtracting 9, subtracting 8, subtracting 7, subtracting 6. So we're going to subtract 5 from 40 and get our answer of 35. Patterns. We're just looking for patterns. So similarly here in number 8, we see the fraction 1 over 2, and then we see the fraction 2 over 3, and then 3 over 4, and 4 over 5, and 5 over 6, and 6 over 7. Hopefully you can see the pattern there. We're adding 1 to the numerators, and we're adding 1 to the denominators. So the next number in our list, we're going to add 1 to that numerator and add 1 to that denominator and get our answer of 7/8. All right. Is it clear enough? Let's see here. Make sure you see these numbers. 7/8. All right, so that is using inductive reasoning to predict the next number in a list. Next kind of question you might see, something like this. This is using inductive reasoning and coming up with a formula. So here it says pick a number. So when it says pick a number, label that number. Use any letter you want to label that number. I'm going to call it X. Okay, so X is a number. Any number. Then it says take that number, multiply it by 8. Okay, well, there's the number multiplied by 8. All right, then it says subtract 4. So we take that and we subtract 4, right? Subtracting 4. And then it says divide by 2. We take what we have and we divide by 2. All right, so dividing by 2. And then add 2. All right, then we're going to add 2. So let's look at this as 8x over 2 minus 4 over 2, so that we can simplify it a little bit. This becomes 4x minus 2. All right, 8x minus 4 over 2, we can split up into two fractions. 8x over 2, which reduces down to 4x. Negative 4 over 2 reduces down to negative 2. And then it says as a last step, add 2. So 4x minus 2 plus 2 leaves us with 4x is the number you get 4 times the original number, your answer is yes. Okay, so that's how you show that is true. Pick a number, label that number. Multiply it by 8, now we have 8 times that number. Subtract 4, we have 8 times that number minus 4. Divide by 2, we have 8x minus 4 divided by 2. Again, we split up into 2 parts, 8x over 2 and negative 4 over 2. That reduces down to 4x minus 2. We then do the last step of adding 2. We end up with 4 times the original number, which was the question. So that is how you do those problems. Okay, number 12 is just kind of a trial and error sort of thing. Is the product of an odd number and an even number always going to be even? Well, think of an even number, any even number, 2, 4, 6, 8, whatever. If you add an even number to itself, you're still going to get another even number, right? Well, multiplication is just repeated addition. So no matter how many times you multiply an even number, whether it be by an even number or an odd number, you're going to end up with an even number, right? So this is going to be a true statement. There's no real formula for this. You just have to think about it, look at examples. If you can come up with a counterexample, if you can find an odd number and an even number that you multiply and get an odd number, then you would say this is false. But this is true. Yes, this is true. Is your answer. And again, because an even number added to itself, no matter how many times, is going to still be an even number, even if the multiplication is an odd number. All right, and now this is asking you the difference between inductive and deductive reasoning. There's a video on the Canvas page from YouTube explaining the difference between inductive and deductive. Basically, deductive reasoning, you're using a general example to come to a conclusion. Inductive reasoning, you're using a specific example to come to a conclusion. So here, all pentagons have 5 sides. Figure A is a pentagon. Figure A is not shown. It's just a theoretical figure. But figure A is a pentagon. Therefore, figure A is 5-sided. So you think about this and you say, did they use a general example or did they use a specific example to come to this conclusion that figure A is a 5-sided figure? Well, all is your key word there, right? All pentagons. When you see all pentagons, that's using a general example. All pentagons have 5 sides. This figure is a pentagon. Therefore, it must have 5 sides. This is an example of deductive reasoning. All right? If you use a specific example to come to a conclusion, that's inductive reasoning. I believe one of the questions has something to do with the Atlanta Braves. It says the Atlanta Braves have won their last 5 games. Therefore, the Atlanta Braves will win their next game. Okay, so they're using those 5 previous games as a specific example. They won these 5 games. They didn't win all their games. That's an example of inductive reasoning. All right, and then the last thing you want to know is how to complete these magic squares for section 1.1. Okay, a magic square is a square where all the rows, columns, and the main diagonal all add up to the same number. And you're given pieces of that square and you're asked to fill in the rest. So here, again, all rows, columns, and the main diagonal add to the same number. We don't know what that number is yet, but we see that the main diagonal is already filled in. So we can get the number by adding the numbers along the main diagonal. Okay? And that's going to be the same as this diagonal. But we have these numbers. Okay, so 23 and 18, that's going to be 41. 41 and 13 is 54. 62, 65. So the main diagonal equals 65. So now we know every row, every column adds to 65. So we pick out a row that has 4 out of 5 numbers. So we can easily know what that number is going to be because we know the whole column here has to add up to 65. So we got 15, 25, 48. So the difference between 65 and 48 is 17. So we'll put that in and we'll circle it to show that that's a number that we've come up with. Okay, so 17. And now we just keep doing it. Oh, here's another column that has 4. 19 and 22 is 41, and 15 is 56. So we have to add 9 to make it equal to 65. Now this row has 4 numbers. 17 plus 5 is 22, 35, 44. So we know this has to be 21. Here's another row with 4. 18 and 22 is 40, 51. So we know 14 has to go here. We got this column with 4. 16, 37, 45 makes this a 20. Fill in this row. 23, 30, 41 leaves us with a 24. Okay, so you see what's going on here? We're just filling in the pieces of the puzzle. 24 and 5 is 29. 29 and 18 is 47. 53 leaves us with a 12. Row of 4, 16 and 8 is 24. 36, 40 makes this a 25. And last one, 7, 32, 45, 46. So that leaves us with a 19. And now we can check and make sure that they all add up to 65. 15, 25, 48, and 17 gives us 65. 24, 36, 41, 59, and 6 equals 65. 7, 32, 45, 46, and 19 equals 65. 20, 28, 49, 51, and 14, 65. 3, 19, 28, 50, and 15, 65. Rows 35, 42, 62, 65. 4, 16, 41, 49, and 16 equals 65. 17, 22, 35, 56, and 9, 65. 10, 28, 29, 43, and 22. Everything's working out. 29, 48, 50, 65. 11, 23, 36, 50, and 15, 65. Okay, that's how you do a magic square. So these are the things you want to know from section 1.1.